This video will deal with the secondary parts of an ellipse, the lattice rectum, and the directrix. So we will build those up from scratch so you can hopefully remember how to work them. First thing, for an ellipse, remember that a squared plus b squared equals c squared. So if this is c here and this is b here, then a is the hypotenuse of that triangle. Then from down here, e equals c over a. And as you can see here, E is the eccentricity, E is 0 for a circle, between 0 and 1 for an ellipse, equals 1 for a parabola, greater than 1 for a hyperbola. And then also we're going to bring these points up. So we're going to call this right here D. We will call that right there F, and we will call this P. Focus, point, directrix. So for all conics, PF equals EPD. The distance from P to F is E times the distance from P to D. So now we're going to derive how to get to this formula for the directrix. Now, the distance from P to D, I'm going to add one more line here. We're going to call this distance D, done in blue so you can see it goes to this line right here. Now we're going to go back to yellow for the derivation. So PF right here, that is A minus C equals E times EPD. So that's D minus A, D minus A. So then A minus C equals ED minus EA. So then A minus C plus EA equals ED. Now A minus C, remember E is C over A times A, cancel and cancel, ED. Now we're left with minus C plus C. So then A equals ED. So then D equals A over E. Now that is A over 1 times 1 over E, which then equals A over 1 times E is C over A. So 1 over E is A over C. And that gets us to A squared over C. And that is this second one right here. You don't have to know the derivation to know it. You just have to remember this, but it helps to know where it came from. Remember what? So now we move on to the derivation of the length of the lattice rectum. Before doing that, let us establish a few things. The lattice rectum is the chord of the ellipse perpendicular to the major axis going through the focus. So half of the lattice rectum goes from here to here. And then let's establish the distance from this point on the ellipse to the directrix right there. Now let's also establish a variable for the distance from the y-axis to the directrix. That variable is d. So for the lattice rectum, we are going to establish the length for half of it from here to here, because that's what we have here. So the distance from the point on the ellipse to the focus is going to be called L, point to focus, and that will equal E times the distance from the point to the directrix, which will be D minus C, D minus C. So now L equals ED minus EC, which now plugging in for E, that is L equals C over A times D minus C over A times C. We'll call that C over 1. So then, as we've established before, that is C over A, and D is A squared over C minus C squared over A. Cancel those. We're not going to cancel the A's. You'll see why in a second. L equals then, we've got a common denominator, A squared minus C squared over A. And remember that in an ellipse, A squared equals B squared plus C squared. Therefore, A squared minus C squared is B squared over A. And that is how we get this. The end point of the lattice rectum is AE, and the y coordinate is B squared over A, which is what we have here. Will you need to know these for your class? Who knows? But it's good to be able to derive them from scratch, just so if you absolutely have to, you can do it.